Good morning, class. Today we are going to start Chapter 6, Algebra, Equations, and Inequalities. We'll look at Chapter 6.1, Algebraic Expressions and Formulas. Our objectives today are to evaluate algebraic expressions, use mathematical models, understand the vocabulary of algebraic expressions, and simplify algebraic expressions. So let's start with some definitions here. Algebra uses letters like what are called variables, such as x and y, to represent numbers. An algebraic expression is a combination of variables and numbers using the operators of addition, subtraction, multiplication, or division, as well as powers or roots. Examples of algebraic expressions are as follows: x plus 6, x squared minus 6, 6x, the square root of x plus 7. Now, we have an order of operations agreement that we follow, and we follow it here as well. First, we perform operations within the innermost parentheses and work outward. If the algebraic expression involves a fraction, treat the numerator and the denominator as if they were enclosed in parentheses. Number 2, we evaluate all exponential expressions. Number 3, we perform multiplications and divisions as they occur, working from the left to the right. Number 4, we perform additions and subtractions as they occur, working from the left to the right. So let's evaluate an algebraic expression. We are going to evaluate 7 plus 5 parentheses 4 minus, x minus 4. Let's restart. We're going to evaluate 7 plus 5 parentheses x minus 4 close parentheses to the third for x equals 6. All we are doing here is plugging 6 in for our x variable. So we have the equation 7 plus 5 parentheses x minus 4 to the third. We are going to substitute 6 in for that x. So we get 7 plus 5 times parentheses 6 minus 4 raised to the third. We have replaced the x with 6. First, we will simplify what is in the innermost parentheses. So we will simplify the 6 minus 4. And that is how we get this 2. Right here. So the 6 minus 4 gives us the 2. Now we will evaluate the exponential expression. So the 2 raised to the third power. 2 raised to the third power is 8. So this piece transpires down to 8. 2 times 2 times 2 is 8. Next, we look at our multiplication, our 5 times 8. 5 times 8 is 40, so we can simplify that piece. So we've taken care of our parentheses, our exponents, our multiplication. Now all we have to do is take care of our addition and subtraction. We just have to add these 7 plus 40, and we are done. The answer to our algebraic expression here, once 6 is substituted in for x, is 47. Now let's look at formulas and mathematical models. An equation is formed when an equal sign is placed between two algebraic expressions. A formula is an equation that uses letters to express a relationship between two or more variables. Mathematical modeling is the process of finding formulas to describe real-world phenomena. So in example 4, we model caloric needs. The bar graph shows the estimated number of calories per day needed to maintain energy balance for various sex and age groups for moderately active lifestyles. Moderately active means a lifestyle that includes physical activity equivalent to walking 1.5 to 3 miles per day at 3 to 4 miles per hour, in addition to the light physical activity associated with typical day-to-day life. We can see over here in our actual bar chart or bar graph that we have 6 different groups here. Those groups are made up of different age ranges. The first, group 1, is made up of an age range from 4 to 8. Group 2 is age range 9 to 13. Group 3 is age range 14 to 18. Group 4 is age range 19 to 30. Group 5 is age range 30 to 50. And group 6 is aged 51 and over. And what we see is that as we age here, we take more caloric needs to a point, and then that point starts to come back down. Now this group is also broken up into female and male categories. the female being represented by the reddish color and the male being represented by the orangish color. So the mathematical model F equals negative 66x squared plus 526x plus 1030 describes the number of calories needed per day F by females in the age group X with moderately active lifestyles. According to the model, how many calories per day are needed by females between the ages of 19 and 30 inclusively with this lifestyle? Does this underestimate or overestimate the number shown by the graph, and if so, by how much? So the way we solve this one is because the 19 to 30 age range is designated by group 4, we substitute 4 in for the X in the given model. Let's go back quickly, and you can tell here that this age range, 19 to 30, is indeed our group 4 age range. Now we could tell that in this group 4 age range for females, we can expect them to need around 2,100 calories per day. Let's see how close our mathematical model, the F equals negative 66x squared plus 526x plus 1030. Let's see how close this gets us to what is actually in the graph. So what we are going to do is substitute that 4 from group 4 in for our x here. So we take our function f equals negative 66x squared plus 526x plus 1030, got a little tongue-tied, and we plug in the 4 for the x. As you can see, it's highlighted in red. So we get negative 66 times 4 squared plus 526 times 4 plus 1030. Now, if we simplify this, 4 squared is 16. We can just continue to bring the rest down. So negative 66 times 16 plus 526 times 4 plus 1030. Now we're going to multiply our terms. That is our next thing to do, because the first thing we did, we looked for parentheses. We didn't have any. The second thing we did was look for exponents. We took care of those. The next thing we do is multiplication. So we'll do the multiplication of negative 66 times 16. That gives us negative 1056. And we do the multiplication of 526 times 4, and that gives us the 2104. So this next step, we have negative 1056 plus 2104 plus 1030. If we simplify that, we do that addition and subtraction all in one step, we get 2078. The formula indicates that 2078 calories are needed per day by women in the 19 to 30 age range with a moderately active lifestyle. Now, it also asks back here, does it underestimate or overestimate the number shown by the graph? If so, how much? So we found that it takes 2078 calories from our equation. Now the graph itself here says it takes, for group 4, 2,100. So we have underestimated and we want to know how much we've underestimated by. So we would take the 2,100 and subtract the 2,078 in order to find that out. So what we would do here, oops, sorry, 2's are going to cancel themselves out. Got ahead of myself. We would borrow from the 1 here, oops, make that a 0. We would make that a 10, but we need to borrow from that as well, make it a 9. We can do this on a little calculator real quick, no problem. But here we go, it should be 22. So we have underestimated by 22 calories. Easy enough. Hopefully now you can see how we plug numbers in for variables and equations to solve, and how we can compare that to graphs. So let's look at some vocabulary of algebraic expressions. Terms. Those parts of an algebraic expression separated by addition. Example, the expression 7x minus 9y minus 3. The coefficient is the numerical parts of the term. Okay, so the 7 and the negative 9 are the coefficients. The 7 is the coefficient in front of the x. The negative 9 is the coefficient in front of the y. A constant. A constant is a term that consists of just a number, also called a constant term. That is the negative 3. It is constant because it does not have a variable tied to it. Like terms. Terms that have the exact same variable factors. So 7x and 3x would be like terms. We do not have a 3x in the above equation, but if we did, it would be a like term to the 7x. Factors. Parts of each term that are multiplied. So let's look at the property of real numbers. So we start with the property of community property of addition. That's a plus b equals b plus a. We've gone over these properties in the past and you've been tested on them by now. So an example of this property using variables is 13x squared plus 7x equals 7x plus 13x squared. Because these two terms here, because the x has a different exponent in the first one, you can't combine them. But you can add them in both directions and they are the same thing. The commutative property of multiplication says a times b equals b times a, so that x times 6 equals 6 times x. The order doesn't matter with the multiplication here, even with variables. Associative property of addition says that a plus b in parentheses plus c is the same thing as a plus parentheses bc. So if we see in our example here, 3 plus parentheses 8 plus x equals 3 plus 8 in parentheses plus x, which is technically the same as 11 plus x, all the same. The associative property of multiplication, a times b in parentheses times c equals a parentheses b times c. So in our example over here, we have negative 2 parentheses 3x equals parentheses negative 2 times 3 in parentheses times x, which would be the same thing if you multiply negative 2 and 3 as negative 6x. We also have the distributive property. Now this is a big one. In order to continue on with mathematics, you really have to be good at the distributive property. The distributive property says that a times b plus c equals a times b plus a times c. It also says that a times b minus c equals a times b minus a times c. So if we look at these two examples, we'll look at the addition one first. 5 parentheses 3x plus 7 is the same thing as 5 times 3x plus 5 times 7. We have distributed the 5 to both of the terms in the parentheses. And we simplify that further because 5 times 3 is 15. So we can say 15x plus 5 times 7 is 35. So we got 15x plus 35. Works as well with subtraction. So we've got 4 times parentheses 2x minus 5 equals 4 times 2x minus 4 times 5. We have distributed that 4 to both of those terms. The 2x is a term, the negative 5 is a term. We've distributed that 4 to both of those terms. If we simplify this, 4 times 2 is 8, 5 times 4, or 4 times 5 is negative 20. So we've got 8x minus 20. So let's simplify this algebraic expression here. We've got 5 parentheses 3x minus 7 minus 6x. Now, if we look at the solution here, we're going to look at using the distributive property first. We needed to distribute this 5 to both the 3x and the negative 7. So you could see here, to get rid of this parentheses, I've multiplied the 5 times the 3x and the 5 times the 7. And I keep, don't lose the negative 6x on the end. Don't lose it. It has to stay with the equation. Just bring it down. Now, we'll do that multiplication. 5 times 3 is 15, and 5 times 7 is 35. We do that simplification, bring it down into the next step. So we get 15x minus 35 minus 6x. What we notice next is that 15x and 6x are like terms because they both have a singular x in them. So we can group them together and go ahead and make that subtraction. The 15x minus 6x gives us the 9x, and then we still have the minus 35 on the end. We cannot combine the minus 35 with the 9x because they're not like terms. The 35 does not have an x in it, so I can't combine it with the 9x. So we're done. We are done. That is as simple as I can get that particular equation. And that completes chapter 6.1. You should be able to start tackling the homework associated with chapter 6.1 and get plenty of practice in for this particular chapter and section. We will continue on with chapter 6 in the next lecture. If you have any questions, please don't hesitate to reach out via email to me. I'm here to help. And I look forward to seeing you at chapter 6.2.